Today we are going to talk about testing of hypothesis. Okay. So, what are the different types of data we have? Just the broad classifications. I don't want to get inside the nature. This is the two types of data we have. So similarly, we will have two types of tests. So what is qualitative data? Which doesn't have any number, just categories. So if we have two variables, and we want to just take the association between these two, we are going to go for qualitative tests. Understood? This much? I didn't say much till now. All I said is data is of two types, so testing is of two types. So whenever there is a qualitative variable concerned, we won't have any numbers, so there won't be any average, any mean, nothing. So we will have only two variables and their corresponding frequencies, right? We will make a 2 by 2 table or anything more than that, maybe more categories or more dimensions, whatever be it. But we are going to check the association between these two. So that, and in these cases, we are going to use the qualitative tests. Understood, everyone? And whenever there are quantitative data involved, like say height, weight, everything, so we can get a mean, we can get the means of the different samples, and now these samples came from some population, which might be the same population or maybe two different populations, whatever be it. But whenever it's coming from the same population, there should be some segregation. So so the population mean is mu1 and this population mean is mu2. We want to test whether mu1 is equal to mu2 versus alternate, whatever be it. In these kind of cases, we are going to go for quantitative tests. Understood till now? So summarizing, what do we get? For checking association, we use qualitative tests. And what are the qualitative tests we have? One is test for proportion, and another one is chi-square. For comparing means or averages, quantitative tests. And what quantitative tests we have? Z-test, not usually applicable, but okay. t tests for 1 and 2 samples, and we have ANOVA. This is not in our syllabus, but till now this much we have. Understood? Taken down, everyone? Now, what is testing a hypothesis? First, we make a claim. That is, we define the null and the alternate hypothesis. So, whenever you get a problem of testing, you will first have to define the null hypothesis and the alternate hypothesis. Now, what is null hypothesis? What is alternate hypothesis? Further, we need to understand what is testing of hypothesis. We have a population. We cannot go to each and every member of the population. So, what do? We draw a sample, describe the sample, study the sample, and then we go back to the population, and this route map is called inferential statistics. And under that, it's testing. So, what is this? What is specific about testing is that we first make a claim about the population. That say the population average is, say, alpha, something, not alpha, say is equal to x, something. We make this claim, and then we frame our alternate hypothesis, which negates the null hypothesis accordingly, whatever be the case. So, first we will have to define this. What is our claim, like what we are testing versus what is the alternate hypothesis, what can nullify our null hypothesis. Understood? Now how do we make the conclusion about the claim? We make a function out of the sample values, and we call this the test statistic. Understood? This will be different for different tests. So, the first step is this. The next step is define the test, or at least name the test you are using. and after that define the test statistic. Which you know the chi-square will look like something like this. T will look something like this, you know. So this is how you define it. But defining chi-square like this is not enough. Or T distributions like this is not enough. We will have to write the degrees of freedom here. We will have to define the test statistic along with the degrees of freedom. And after that, calculate the test statistic. The next step, what are we going to do? Define the critical points, critical values. Now, what are critical values? We know the distribution of the test statistic. We denote these areas by the 5% points. Like if it is a right tail test, we will give 5% here. If it is a left tail test, we will give a 5% here. And if it's a both side tail test, we will just divide the 5% into 2.5% on both the sides. So this side for 2.5%, we just have these points. So if the value of the test statistic goes beyond these points, then we can say that the fluctuation that is happening due to which the test statistic is going beyond these points is not due to random causes, there is actual difference, right? So if it falls here or here, we will say that we reject the null hypothesis, okay? But if the value of the test statistic falls here, we will say we fail to reject the null hypothesis. We fail to reject the null hypothesis. So here, conclude about the tests. So what are the two kinds of conclusion? One, we reject the null hypothesis. We fail to reject the null hypothesis. These are the two types of conclusion which you can come to. Do not write things like we accept the null, so the null is true. No, we don't write anything like this. And then draw your conclusions. Now, what is the conclusion out here? Say the question has given us that average weight of group A is greater than is significantly different than that of group B or not. So after doing the test, we have rejected the null. So for this test, for this step we are going to say we reject the null hypothesis, and for this step we are going to write yes, the average weight of group A is significantly different than that of group B. Understood? So we need to conclude our remarks. Till now understood? So this is how you guys should have to write the answers. You guys are writing things which are not necessary. You write this down. Write this thing down. Write this much down. And please stick to this while you are writing your answers. And yes, another step I forgot. Define the level of significance. What is level of significance? Say we can allow 5% error. So we will say our level of significance is 5%, or alpha is equal to 0.05. Just write this much. The cutoff points change according to the level of significance. So you should define it. We can hope that it will always be 5% for you all, but still you need to write it. Bonus point, you can just write, if the alternate hypothesis is like this, then you can, so it is a two-tailed tests. If the null hypothesis, alternate hypothesis is like this, it is a left tail test. And if it is like this, right tail test. That is, this will make your answer even more proof, error free. Taken down? Two tail test, left tail test, right tail test. Everyone taking it down? Now let's just dive into the tests. First test, chi-square test. Chi-square test. So first let's grab a problem and do it accordingly. অঙ্ক খুঁজে বের করি chi-square বাবা কোথায়? এই তো। This sum was given to you in your exam sheet. কোনটা এটাই দেখি তো আছে কি? Yes. Are you guys familiar with this sum? Came in your exam, practical exam. Just the numbers were different. This same problem came. I only set the exam. So yes. So here the question was given like whether being vaccinated is anyway related to getting the disease or not, right? And how was the data given? 20 people who were vaccinated got the disease. 180 people who didn't get who weren't vaccinated who were vaccinated didn't get the disease. 52 people who were not vaccinated did not get the disease, and 148 people who were not vaccinated did not get the disease. Understood? This is for disease occurred, this is for disease not occurred. This is for vaccinated, unvaccinated. Understood? So, and the question was, is there any correlation or is there any association between being vaccinated and having the disease? So first let's try doing it using chi-square. কালি আছে গো, কালি আছে, হ্যাঁ রেড দরকার নেই, কালো নীল এগুলো তো পড়বে তো কালি। So here we are going to use the chi-square test. For association. Understood? Okay. Is there any association between being vaccinated and having the disease? It can be also framed like this: will the vaccinated people are the vaccinated people more prone to the disease or less prone to the disease? It can be framed like that also. So I am removing it because we are going to solve it the way I told you. So what was the first step? Defining the hypothesis. So H naught, there is no correlation. Versus H1, there is some correlation. You can also write association. So this is the hypothesis for chi-square test. There is no correlation, there is some correlation. So this is the first step. We will have to write this. What was the next step? You guys tell me. So what test are we using? Now chi-square statistic. Test statistic is equal to or colon chi-square is equal to summation OI minus EI whole square divided by EI, and yes, the summation will be here. Understood? Now you are going to write since বোর্ডের জন্য হচ্ছে হ্যাঁ টেস্ট সিরিজ এটা মুখস্থ করবি তুই, আমি ভালো করে লিখে দিচ্ছি। হ্যাঁ বলছি, লেখাই তো পড়ছে না ভালো করে, কি করে তোরা দেখবি? সামেশন OI minus EI whole square divided by EI পড়া আছে? Now you are going to write since there you don't have to write this much also. Do you write just write degrees of freedom? এটাকে লেখা কিছু করতেই পারবি না তোরা, সব কটা নিয়ে চলে আসছি যেটা পরে পড়বে। Degrees of freedom R minus 1 into C minus 1, and usually you will be given 2 cross 2, so you will going to do it like this. But there can be cases where these are 3, 4 and the cutoff values will be changing accordingly, but just put the values here and you get the degrees of freedom. Understood? Next step, level of significance. What is the level of significance? 5% or 0.05. Next step, calculate. Let's write calculation of test statistic. Then we calculated test statistic. What were the values? Wait, let me take out the values. So let's calculate the test statistic. The values here are 20, 52, 72. I'm not going to take the total. I'm going to do it with you all. 180, 148. These are the values which were given. Oh yes, another thing. Right here, right, where OI is equal to observed frequency, EI is equal to expected frequency. Everyone was writing experimental frequency. I don't know why. It is expected frequency. And for EI, just write it is equal to and give row total into column total divided by grand total. Just write this much. This was in the step of the test statistic definition only. So let's calculate the test statistic out here. So we draw another table where we have draw the like expected frequencies. So how much is the expected frequency? Let's get the total. 72. How much is this? 8 to 328. How much is this? 200. How much is this? 200. So how much will this be? 200 into 72 divided by grand total 400. How much? You just write here table for expected frequency. How much? This will be 36. 36. How much will this be? Ah, 328 into 200 divided by 400. How much will that be? 64. 164. How much will this be? 72 into 200 by 400. 36 again, 164 again. Correct? এই ভ্যালুগুলো ক্যালকুলেট করে লিখেছি করে দেখ 200 into 72 divided by 400 36 200 into 328 divided by 400 164 same goes for this. Understood everyone till now? So let's substitute these in this equation, in this value. Let's see what we get. Right, therefore chi square is equal to, and just calculate it, 20 minus 36 divided by 36 and put a square here, plus what, 180 minus 164 square divided by 36, not 36, 164, plus 52 minus 36 square divided by 36, plus 148 minus 164 whole square divided by 164. How much will that come out to be? 16 square by 36 plus 16 square by 164. I mean, I'm just doing the calculations, even if this is not readable. I'm just doing the calculations only. This work. Yes, it's working. 164 plus 16 square by 36 plus 16 square by 164. So whatever that comes out to be, what is 16 square? 256 into 512. 512 divided by 36 plus 512 divided by 164. Whatever that comes out to be. So from here we have got the value of the test statistic. Just calculate this and tell me. Just calculate this and tell me the value. This much you guys can do. Tell me the values. হাতে কর, এই হাতে কর, ক্যালকুলেটর আমার কাছেও আছে। অ্যাড করে 17.34, okay, and I am telling you for this sum the cutoff value is 3.841. So this is greater than 3.841, greater than 3.841. So what will be our conclusion? We reject the null hypothesis. So conclusion for test is since chi-square observed, chi-square observed is equal to 17.34 greater than chi-square tabulated is equal to 3.841, we reject the null hypothesis. We reject the null hypothesis. And in the last step, what will be our conclusion? So we conclude that there is some correlation between getting vaccinated and having the disease. Understood? So we conclude that there is some correlation between and also another thing, for chi-square test there is no right tail left tail, it's only one type only. It is always positive, chi-square is never negative, that is one thing. So proportion, first we need to segregate the population. So let's consider the previous problem only. ছিল ভালোগুলো what are these 200 people? The people who took the vaccine. Here is vaccinated, here unvaccinated. Here is disease occurred, here is disease didn't occurred. So these 200 people are vaccinated. These 200 people are unvaccinated. So this is one population of vaccinated, this is one population of unvaccinated. What are the 72 people who have got the disease? What are these 328 people who didn't have not developed the disease, right? So either ways we can segregate the population in two different status. Possible? So we say we take these two. Obviously, when these two, we are taking these two in consideration, these two won't be, these two will be the variates, not the different populations. But if we consider these two, then these two will be the variates. So let's consider this one because of the ease of calculation. So what is the proportion of people who have got the disease among the vaccinated ones? 20 by 200, correct? What is, we are naming it P1. Let's write P2. What is P2? The proportion of people, patients who have got the disease amongst the ones who were not vaccinated. 52. Now we define Q1 is equal to 1 minus P1. So 1 by 10, 9 by 10. And we define Q2 is equal to 1 minus P2. What will that happen? Come out to be. This much defined. Now, the test statistic Z is equal to P1 minus P2 divided by standard error of P1 minus P2. What is standard error of P1 minus P2? Root over P1 Q1 divided by N1 plus P2 Q2 divided by N2. And yes, we take the modulus. Can you tell me why do we take the modulus? Because we don't want to consider the negative part. That will also fall this side only, right? Like whenever we are drawing a graph like this, if we take a modulus, this thing will get replaced here only, right? So minus 1.96 part will get transferred here only. So if it's here, it will get transferred here. So that is why we add the modulus. So the cutoff point is 1.96. So if the value of this Z crosses 1.96, we are going to reject, else we are going to accept. Solve it and tell me the answer. In a proper fashion, the way I told you, properly, like what is the null hypothesis here? Null hypothesis is P1 is equal to P2. Now there is one thing, I don't think that you guys have one-sided tests in your syllabus. It is always two-sided only. So you are going to write this, P1 not equal to P2. Because logically here it should be greater or lesser. But according to our problem, it's 1.96. Solve it and tell me. Also, what is this N1, what is this N2? We have taken these as samples, the vaccinated one as sample, the unvaccinated sample. So, N1 is 200, N2 is 200. If had we done it like this, then N1 would have been this and N2 would have been this. The proportions would have been calculated like the totals will be 72 out of 20 out of 72, 52 out of 79, like that. I hope you guys have taken down till now, so I can rub the board. Whatever of water. Calculated 73.05, 1.96 is Onic basic. Way greater than, which one is 73, how this much? The test statistic or the standard error? Z square, Z. Like Z is equal to P1 minus P2 divided by this. This is how much? 70. 73.05, maybe yes. So this is way greater than 1.96. So what do we conclude? We reject the null hypothesis. So in both ways we get the same result. So this is how testing of hypothesis works for qualitative data. I hope you guys can write the conclusion here. I hope you guys can write the conclusion. Let's rub this out. So we have now understood the qualitative test. Now for quantitative tests. Now wait, one thing. Before going on to quantitative test, let me tell you guys when to use the chi-square test and when to use the z-test. Z-test is used when the sample size is greater than 30. Sample size is greater than 30. There are only two categories. More than two categories, z-test won't work. Only for two categories it will work. And for more than two categories, when the sample size is less than 30, any case, we use the chi-square. But usually z-test is easier to calculate compared to chi-square. Chi-square is very tedious. Now to quantitative tests. What are the two tests we have? Z, T. Let's focus on T test first. T test is of two types. One is paired T, another is unpaired T. Now what is paired T and what is unpaired T? Say I have say 10 people with me. I measure their weights before giving them a medication and their weights after giving them a medication. Okay, a particular guy has weight X before the medication and X plus alpha after the medication, correct? These two weights will have some correlation between them, right? Like a person who was say 70 kilos can expect to go 72 kilos, but the person who was like 20 kilos won't expect to get 72 kilos, right? We can expect that guy to go to 30 kilos. So there is between these two. So in this case, when the population is the same, just segregated in different ways, then we are going to use the paired T. And suppose we want to make conclusions about, we have two populations, we draw two samples and we want to compare the averages of these two populations. Then, and these two populations have no correlation between them. In this case, we use the unpaired T. So that's all. Now let me write the test statistics down. Acha, tell me one feature about paired T. Since the sample is the same, we will have the same number of data. Like, I have 10 people, I measured their weights before giving the medication, after giving the medication. So I have 10 values for people before the medication, 10 values for people after the medication, right? But for unpaired T, we cannot say that both the samples will be of the same size. Okay. So now for the paired T part, I'll write down a test statistic. Wait. First we find the difference. Di is equal to summation say xi minus yi. No modulus, just like that. What is Di? Summation xi minus yi. Like this guy had weight 72. This guy, he turned out 70. This guy had weight 60. He turned out 65. So xi minus yi will be 2 minus 5. Understood? Understood till now? Next, what do we do? Find the average of di. We find d bar. Di means not summation, sorry. Di is equal to xi minus yi. D bar is equal to summation xi minus yi divided by n. What is this n? Number of pairs. N is equal to number of pairs. Wow, what is the number of pairs here? 10. 10 pair of weights we have. And divided by, and now for the test statistic part, T. Test statistics always look like this. The difference over on the top, the standard error on the bottom. Always it looks like this, other than chi-square. Always it looks like this. Now for the standard error part. Standard error part is very easy. Just let me wait 1 second. এটা জাস্ট মুখস্থ হবে. You will get this memorized by heart. Find the value. Tell me the answer. SD square here. SD square here, or you can write it like this. Yes, there. Cockpit taken down. Now degrees of freedom. What is the degrees of freedom here? What is the degrees of freedom here? Tell me. N minus 1. Okay? N minus 1. Now for paired T we have got it. Now for unpaired T I am writing the test statistic. Okay? Unpaired T. The test statistic will be given by similarly x bar minus y bar. Why cannot we find the difference here? Because there won't be any one-to-one correlation here. There was one-to-one correlation. The guy who was getting it versus the same guy who didn't got it at the beginning. And here we have a different size sample, and this is a different size sample. We have an average here, we have an average here, and then we scale it down here. Okay? Divided by same standard error of x bar minus y bar. Now write standard error of x bar minus y bar. SD square into SD into root over 1 by n1 plus 1 by n2. Okay, সোজা হয়ে বস। And what is SD? Root over n1 minus 1 SD1 square plus root over n2 minus 1 SD2 square divided by n1 minus 1 plus n2 minus 1. এই ফর্মুলাটা SD is equal to root over n1 minus 1 into SD1 square, n2 minus 1 SD2 square divided by n1 plus 1 n1 minus 1 plus n2 minus 1. Understood? What is the degree? What is the degrees of freedom here? Degrees of freedom here is n1 minus 1 plus n2 minus 1, which will come out to be n1 plus n2 minus 2. Same you can write that here also, or you can write understood. Now let's do some sums. Oh, check this out. The mean hemoglobin of 407 students from rural was 11.4 gram percentage or what something I don't know, and SD 1.3 G percentage, and from the urban area 459 students, mean is 12, SD is 1.9. Tell me whether there is any significant difference or not. What test will be used? Unpaired T. See, 407 students are coming from the rural background and 459 students are coming from urban background. So I guess these two populations are completely different independent of each other. Now, the sample size, the population sizes are also different, the sample sizes are also different. So what are we going to use? Unpaired T. What is unpaired T? You just did right now. Calculate. You don't have to calculate the mean and the SD different separately here because it is already given, but in real life you might have to calculate that also. হয়ে যাক, তারপর জেড টেস্টটা করিয়ে দিই। Calculate and tell me the value. করে ফেলেছিস? হ্যাঁ করে তাকিয়ে রয়েছি। It's a tedious calculation, but I want you guys to do it because পরীক্ষার হলে ক্যালকুলেশন করতে গিয়ে somehow ওদের খুব সমস্যা হয়, আমি দেখেছি। You want me to do with you or you can do it? হাতে কর না, সেটা ফ্যাক্ট। যাই হোক চল, যে টেস্টটা করে দিই, তোরা এটা ক্যালকুলেটটা করে আমায় জানাস। যারা করার ইচ্ছা আছে করে আমায় জানাস বাবা, ওয়েট করে সময় নষ্ট করে লাভ নেই। জেড টেস্ট, যখন আমাদের স্যাম্পল সাইজ গুলো গ্রেটার দেন 30 হয়ে যায়, তখন একটা মাচ ইজিয়ার অ্যাপ্রোচ হলো জেড টেস্ট করা। জেড টেস্টের টেস্ট স্ট্যাটিস্টিকটা কি? whenever our sample size is greater than 30, the Z test will be a much easier way. Oh, I'm so sorry. So, whatever you are doing there, this thing is much easier to do. Much easier to do. Because here the sample sizes are in themselves greater than 30. Correct? Here the sample size is greater than 30. So, we can use this one. Correct? This is much easier. This is much easier. This way. So, this is how you do the Z square, Z test, and whatever the value of Z is, if it is greater than 1.96, we reject, else accept. The modulus. So now you know how to do it, do every type of test. So if I see one more answer sheet with ridiculous answers, I'm gonna like deduct marks you can't even imagine. Put 0. So last So last, let's give a recap. So what can we conclude here? Easier but applicable when only n greater than 30 and there are only two categories. Chi-square, yes. Z-test whenever n greater than 30, easier to compute. T-tests, we have two T-tests. What is one? Paired, unpaired. I am not explaining this again, you know this.